Hey, welcome back to the stream, folks. It seems like Tuco's here to greet everyone also. My cat and I are back at it again, working out of this sort of virtual hacker space that we have. And so the thing that we do here is work on projects and film it and stream the work in progress, but then also put together videos about the final results of those projects, or good milestones at least for the big ones. So here I am. If you go to scanlime.org, you can see some of the previous videos that I've done using this process. They tend to get pretty in-depth, so they're a little infrequent these days, but I keep trying to figure out how to mix up the content to have little, kind of smaller projects intermixed with the larger projects so it doesn't get too monotonous. Anyway, on this video I'm here to, first thing, just kind of show off a milestone that I got to just from some coding today. This was a continuation of some work I did on stream yesterday to try to get some just like time series data logging for this robot. So if I scroll down a little bit, this latest video is about the gimbal, but the stuff I'm working on right now is actually trying to get some smarts behind a cluster of these Winch Bots all working together. So the idea behind this is that this is a kind of smart spool of cord with some sensors on it and a microcontroller and an Ethernet interface, and there's a central computer controlling all of these winches together to move the robot around the room by kind of pulling it around on pulleys. So we've gotten kind of to that point, and I'm starting to try to dial in the motion of these winches to improve the quality. Geez, Tuco really wants me to play, and I was just like absent-mindedly playing with these gears on the table, which now means I have lube on my fingers. I should carefully throw one of these bolts for Tuco, and then maybe go wash my hands in a bit. Anyway, yeah, my cat likes plastic bolts, in case that wasn't already a thing you were aware of. Yeah, so we went through some of the architecture in the WinchBot video from earlier. It's basically a daemon written in Rust that runs on a PC, which then talks to all these networked microcontrollers that are actually pulling stuff around. The microcontrollers do very little. They're running a really basic PID loop. Excuse me. They run a basic PID loop and some safety checks, but most of the smarts is intended to be on the central computer where it's easy to modify. So the interface we had been dealing with up to this point, I guess I forgot to open it on this computer. Let's see if I can just mount the disk. Just a moment while I fuss with file system-y nonsense. Can I get Tuco on the screen, by the way? Usually I have this work in progress camera at least set up enough to aim at the cat while we're doing this. Yeah. Where is he? He was usually hanging out around here. Oh, there he is. Oh, apologize for the little bit of swinging on the camera there. I think I recently bumped it when I walked past. So the swinging, I'm curious what the swinging will be like when I get it mounted on the actual winches. There will be some things working to make it better and some things working to make it worse. I mean, there's just a lot more cord and more stuff to bounce in the system, which could make it worse. But I've also got the whole tension in the system working to kind of pull the plane of the robot toward the plane of the pulleys, which could work in my advantage. Yeah, I don't think this is quite going to work. Where is he? Oh, he came back over here. This would actually be easier with an overhead camera on the same screen. I guess I could do that. Oh, nice. Looks like I inspired Bunny Overlord to use YOLO in an academic project. That's pretty cool. Yeah, YOLO is the object detection library, or rather the neural network architecture that we're using for the bot right now. That's what's actually detecting that it's a cat. It's also detecting a bunch of other stuff that currently we're just using in debug mode. And he's over there where I can't see him right now. Anyway, we can go back to the computer. I figured out where the right file system was. Let's see, so we can access the interface for the robot actually by opening up this web interface, which is actually, you can get it via a QR code or with this URL. So I'm actually just going to open that. I guess I can't copy paste that directly from the preview window. But if I copy paste that from here, that'll actually hook me up to the like internal console for the robot. And so this is something I've been developing the client side of this with React. It's like written in JavaScript, of course. So it's with React, and I have a lot of these charts that are drawn by this cool JavaScript library called Smoothie Charts, which I should definitely plug here. So yeah, this is the actual rendering library. This is what draws the chart, does the like interpolation and auto-scaling and whatever else. This is what eats all the CPU. It's funny because like I've written a bunch of libraries to draw these kinds of charts in the past for like performance tools, and so I had this library in Python I was using for a while that was like very careful to like draw the minimum number of pixels possible, and then this thing just like blows through tons of CPU, but it's fine. So if we go down to just one of these bots, you can see a little bit more because you can actually see the noise on the sensor. But if I am on the all bots view, I can just drive this around. If I actually use the right joystick, and it's actually pretty responsive. So the lag you're seeing right now is actually mostly due to the bot's control loop, which is something I'd like to address maybe in near the end of this stream. But so the whole point of this console is to have a really easy way to just connect and get just like a real-time graph. There's designed to be very little latency between here and there. What's something where I can actually see the latency better? I mean, if I'm not actually controlling the bot, but just looking at the sensors, I can actually see the latency pretty well. So bot 0 is over here next to me. I think I can just like reach over there and poke at it. Oh, right. I should halt the other robots because otherwise they're going to move in response to that. So yeah, let's put that in halt first. Alright. So just to like hold this, let's see if I can get this on camera. So I think you can see the little impulses that I'm sending down this cord by plucking it. I think this is maybe the best demo of the like real-time nature of this web app that I'm going to get right now. But yeah, the whole point of this is it's pretty low latency. We could go measure that in the video editor or something. I'd have to compensate for the difference in lag between the different input sources on my streaming rig, though. But the whole point of this is very fast debugging. But I was starting to run into problems where I wanted to like take a really close look at some like little particular behavior that the winches exhibited during some test, or I want to like save out a bunch of data from a test run, or you know, I want to like look at data from a larger like time scale in order to see broader trends in like how the load cells stay in calibration or don't over time. So for that kind of thing, I really want an ability to store this data and not just have it stream out like it is right now. So the Rust server it's just optimized for handling this data really quickly. Internally, it has just a like fast inner process message bus that based on some Rust components, and that handles data at the full rate that we're getting it from the hardware, which is in the neighborhood of between it's around 1.2 thousand messages per second. Yeah, normal people would say that 1,200 messages a second. Yeah, a little bit more than that, but it's approximately one message per tick per robot, and the tick rate is 250 hertz. Oh yeah, sorry, I'm behind on some of the questions. I try to actually answer the questions in all the chats. There's the native chat on YouTube and Twitch where I'm streaming, and then there's the Gitter chat with the URL right there in case you'd like to join us to chat between streams. Oh, how did I un-autofocus by pointing at the URL? That's a nice Easter egg. Yeah, so we chat there between streams too. Yeah, Station 240 says, I looked at the title, no idea what half that software is. You and me both, if you would have asked me last week. So, I mean, except for Smoothie Charts, because I've used that a bunch at this point. But yeah, the other two pieces of software they ended up using for this, which are in the title, Chronograf and InfluxDB. Like, I'd heard of InfluxDB before, but I didn't really know what it was for until I looked into it recently. And I'd never heard of Chronograf, and so, I mean, not like... I'd never heard of this particular stupid software misspelling of Chronograf, right? So, yeah. And then, I think that's Money Overlord asking what else I'm using in this project for React for the interface. Oh, it's, what am I using? It's pretty bare bones. Let me pull up the React modules I'm using. So I was going to mention this stuff is all on GitHub if you wanted to like use any of this code or like reference it to see what I'm doing or read any of the like sparse documentation that's there. Everything's under the Tuco Flyer organization on GitHub. And this actually spans a wide range of topics here. There's the actual CAD models for the robots. There's bot controller is the Rust code and the web front end both, because they both kind of need to run at the same time. Like the Rust code runs and then serves the web front end is how that works. And then we've also got some other odds and ends. The computer vision is a separate project in C++ that acts as an OBS plugin. There's a forked version of OBS, which I should really update. I think they actually merged my pull request, so I might not need the fork necessarily. I forget what else is in there. Anyway, there's the actual firmware. All the bots run the same firmware, just with different configuration settings. And Darknet is the neural network library that runs the object detector. Tuco Chat still isn't actually set up yet, but that's like a work in progress, like chatbot bridge for actually helping all of you control this robot, which is still kind of a missing piece. So yeah, the whole point of this is that it's designed as kind of a movable camera platform that you can just set up indoors. So in a big indoor space like this, you can just like throw some pulleys up in the air, like on ceiling hooks, or in my case, mostly over beams and stuff. Put some winches on the wall, run some network cables, and then you have a camera that can just like hang out and stream 24/7. So, and then like use all the computer vision resources you want to throw at it to track objects and stuff. And because it is a wired robot, it doesn't have batteries, it doesn't use like wireless video, it like uses a low latency uncompressed HD video connection, a little coax cable. And because of that, we can do all the computer vision on the ground with a like a big beefy GPU. So it can do nice like high-end GPU object detection, and it can just burn a whole CPU core doing object tracking if we want to. So there's that. So anyway, we've gone into this interface a bunch. It really specializes in like setting up the bot and like checking out its current state, but it's never designed to save anything. Like this doesn't even have a log file really. So that's where I started looking into like what else would I use to store data. I mean, the simplest option would be just be to like dump out log points to a CSV file and then like visualize them with a spreadsheet when I wanted to, but that seemed like a recipe for extreme tedium Like they would quickly start to get big enough that the spreadsheets wouldn't deal with the files and I wouldn't be able to find the interesting regions easily. So using some kind of real time series data management system seemed like a good idea. I've used RDTool in the past for this, which is a pretty nice, very simple time series database that's kind of this classic open source-y, well, open source like Unixy tool that, yeah, produces graphs like this. You might have seen graphs made by this if you lived through the 90s. You probably have if you were any kind of networky person. But it's just a command line tool that manages these kind of fixed size like ring buffer data structures that you can quickly feed with points. But it's it's designed for like logging how much traffic is going through your network, not necessarily like something that's happening multiple times a second like I've got right now. So I was looking at the other options. There's some tools. So it looks like RDTool is basically like the industry standard for a long time, and it was what I was familiar with for a long time. It's written in like kind of crusty old C code that's really not at all possible to integrate directly into another application, and you couldn't really make it a library without completely rewriting it the way it's written. So instead, it's got an API where you can open it as a subprocess and then send it commands over standard in, and it's all right. I've written modules to talk to it that way. There are modules like that for like Perl and Python and whatever else people use in the 90s. And so that would be one option. But RDTool has a lot of limitations that would have been a problem for analyzing this robot data. I think to be useful, I would want granularity finer than just like 1 data point a second, which is what it's really designed for. And so looking at the successors to RDTool, of course people have been developing successors, and there are just a bunch of them. There's one that was popular for a while called Graphite. I think a lot of people still like this one, but it's starting to show its age at this point. Yeah, it's written in Python. It's not the fastest thing. It uses a data structure that's inspired by RDTool called Whisper, and you can get data into it really easily. You can just like send UDP packets at it with like a data point, and then like a well, so actually there are different protocols here. There's like a lower level protocol, but the way a lot of people use this is this higher level protocol called StatsD that's actually emulating this other thing that I think was developed by some engineers at Etsy and ran on this other thing. There are a lot of implementations of StatsD that you can find. So one approach that I was taking for a while is, well, okay, I'll just write to StatsD. That still wasn't my preferred approach, since I wanted something that would be very simple. That's, you might be thinking, this is already sounding so complicated. You just wanted some graphs, right? Well, yeah. So my first choice would have been something that I could have used as a library in Rust, and then just opened a database in process, written directly to it, and then integrated some longer term graphs into my existing web interface. That would have been my intuitive first choice for what to do. And so if something like SQLite 3 existed for time series data, that would be great. I could use it like that, make plots. A kind of close-ish second to that would be using a tool like RDTool as a subprocess, and then just writing my own interface library for Rust. As far as I could tell, there wasn't a good one for Rust that was existing. So I didn't see a good option for that. It looked like RDTool wouldn't really be up to my needs, and I didn't see anything that would be like SQLite for time series data. So I started to think about the problem differently, and to think about, well, now that I know about this StatsD thing, that's this very lightweight, very kind of interoperable protocol for sending your metrics out to a different process where it can get logged and whatever. That seemed like, well, I can just add that to my app without really increasing its dependency burden too much, and it's an easy feature to turn on and off, and people can just turn it off if they don't want it, if they're reusing my code, and I can just set it to some server which I could use to log other things on my network. It would be nice to have some other network monitoring, right? So I was starting to think about it from that angle, and so I tried Graphite, and it was all right, but it definitely seemed like it was kind of clunky, and if I wanted to store like tens of metrics per second, or tens of samples per second for each metric even, then Graphite might not have been able to keep up with that load too gracefully. And so I felt the allure of what seemed like the most modern approach, which was InfluxDB. And InfluxDB is actually, like, it solves a very similar set of problems, but it uses a database that's had a lot more thought and development put into it, it seems like. It's like a log structured merge tree, I think, is what it was using, something like that. Anyway, so if you just look for InfluxDB, you'll find that they've got basically like a commercial plus open source model, kind of like MySQL had or has or whatever, where they have like an enterprisey platform that has clustering, but what you actually want is like, well, they're an open source software company, and all of these components are open source if you ignore their high-end enterprise clustering parts. So you just want to install InfluxDB and Chronograf. These components are all right too. Like Capacitor, I haven't tried it yet. It seems like if we ever want like alerting so that if something's going wrong on the robot and I'm not actively looking at it, which isn't a problem right now because I'm pretty much always actively looking at it, but in the future something like that might be useful. I tried using Telegraf to actually do all my stats collection because, so this is like a way of collecting time series data. If you can't tell, this is like designed for like network operations people mostly, for like keeping tabs on their server farms. And I want to use it to monitor my robot, so it's like a bit of an off-label use, but I think InfluxDB seems like it's plenty fast enough to handle this, it turns out. Telegraf, I'm not sure if that's actually fast enough to handle it. So I started out using Telegraf and its statsd support, and it worked, but I couldn't get it to aggregate data faster than like once a second, which wasn't really good for like force sensor data where I want tens of hertz probably. And even sending data at that rate, well, actually, so what I was doing is I was sending Telegraf data. I had an earlier version of my experiment. I send Telegraf data at the full internal bus rate of like kilohertz as UDP packets. Telegraf then aggregates it down to 1 second. So that was very easy to kludge together. I could just use any old the statsd client for Rust, of which there were a couple available. There is a whole other frustrating rabbit hole I hit because it turns out a bunch of people have written libraries that are almost what I need, except they can't do floating point numbers. And I really want to be able to do floating point stats for stuff like forces and velocities, right? And like, yes, I can make it fixed point. So I started, I got very far down this path of using a library called Dipstick in the previous stream. And I was frustrated that it didn't support floating point. It only supported integers. And so I'm like, okay, I'll just scale everything up, make it fixed point. And then I discovered it only supports unsigned integers. And at that point, it's just like, okay, this is the last straw. I'm not biasing all my measurements too. So that's how we're here. And I'm trying to use the slightly more grown-up tools to do this job. And so when I tried using Telegraf to just like slurp the data out of UDP, that was simple, but I couldn't aggregate any slower than just like seconds. And I think the way I have it set up now in the architecture that I'll show you in a sec, it's aggregating at like 100 hertz, which seems to be about right. But I can tune that now, which is nice. And so in that case, I was getting not as much data as I wanted, and just the Telegraf daemon was burning like 5% CPU on the machine I was running it on. So not a lot of fun. So that brings me to the current approach where Telegraf, well, just like Capacitor, I might install it separately just because it's useful on its own, but it's not necessary for this particular setup. Right now, I'm sending my data directly to InfluxDB. There were 2 Rust crates I found that were InfluxDB clients. The InfluxDB protocol is pretty simple. It's HTTP, so you can use any HTTP library. You can get SSL and authentication optionally, just using standard HTTP, like HTTPS and like HTTP basic auth. So the protocol doesn't really have to specify anything new for that, and the libraries you'll find just tend to use other Rust HTTP libraries and import those features pretty trivially. And then on top of that, it's got a pretty weird protocol where it just like uses the query string and then uses that for like basic like selecting what to do to the database. Like, are you querying? Are you inserting? Those are like different strings that are parsed and then like inserted into the HTTP query command. So there's already a couple levels of indirection. And then the actual measurements are sent as like a list of text lines in a big HTTP post. But the HTTP overhead doesn't really matter too much because since this isn't designed to be real time, you can batch stuff pretty arbitrarily. So right now I think I'm sending like 8,000 metrics at once, and it turns out to be like a couple of megabyte long HTTP post, but it doesn't matter that much. So that InfluxDB just chews that up, logs it on disk in a nice, easy searchable format, and then Chronograf lets us view it. So that's what I've got here. If we just go to the front page, this is all running in Docker right now. If you go to influxdata/sandbox, this is just a thing that they made recently that's it's like a shell script plus a Docker Compose setup that lets you easily set up a little like virtual machine on your computer that runs their stack. So this talks about how to use it. You don't even really need to know how to use Docker that much to get this set up, because it'll just set up all the machines the way it needs them. And if you're not familiar with Docker, it's kind of like virtual machines meets like NPM repository. It's a little bit lighter weight than that because it actually uses kind of containers that exist within a Linux kernel rather than full system images. So you're sharing like the kernel, you're sharing I think libc with the base system image, but then like you bring all the other libraries and that's part of your application. And then it provides some nice network isolation features, and it makes it easy to download the images and keep them up to date and like do clustering. And so all the kids these days love it. I'm sure, you know, everyone who deploys web applications actually, you know, would know like everything about this already, but I'm still pretty new at it. Luckily they have this script where you can run Sandbox up and it starts a whole bunch of VMs on your machine and then just like exports it all to the local network without a password. And so it's like not secure by default, unfortunately, but it is easy to set up. And so I think am I already SSH'd into that machine? Let's take a journey over to the right computer where we can find out what the status of this all is. Where's Tuco, by the way? Oh, Tuke's on the rack. Let's get the camera over there too. Come on. There's some PID loop wind up in the gimbal that I think I'm fighting against right now, unless something else is broken. Oh, it's in halt mode. Ha ha ha. It's in halt mode. I'm always halting the gimbal and then forgetting that, or halting the winches and then forgetting that affects the gimbal too. Wow, are you noticing that roll? That is not level. Okay, that's very off topic for this stream because we're not debugging the gimbal right now. But the gimbal needs some roll compensation. Right? Yeah, that's gotta just be a value that's not set right in the gimbal configuration. Unfortunately, all of the gimbal configuration right now is reverse engineered, so we've got some work to figure out how to get that set up. Yeah, Ethan says Grafana is also great. Yeah, I looked into Grafana briefly. I ended up mostly sticking with Chronograf since it seemed like the kind of official add-on for InfluxDB. But yeah, some people seem to like Grafana instead. I don't really know much about the differences. But yeah, I'm sure a lot of people use it, have seen this on like network metrics if they have any kind of like network operations like web page that they go to. There's a program similar to this, I mean much more basic, that I used to use built on top of RDTool called Cacti, and I used it on my own network for a while. And I remember after setting it up on my own network, realizing that it was the same thing that my university was running earlier. Yeah, I don't know why the gimbal is so tilty, but I mean, I've seen this problem before and I haven't gotten to the bottom of it yet, so it's not a new bug, it's just a thing we haven't gotten to yet. It's just frustrating. I don't know why it's happening more than it usually does right now. I think it might be due to the angle that the gimbal was sitting at when it was powered on. So, because it is hanging a little bit strangely on the stand right now. But I'll need to understand that part better, because I'll need to be able to figure out how to compensate for that and or like restart the horizon leveling, whatever is going wrong, like figure out how to actually tweak that while the thing is flying, because I don't want to have to require that it starts up level, because that's not going to be the case. Anyway, let's go back to the computer. I've wiggled my way into the right computer with Docker running on it. So this is just another machine on my LAN that happened to be something that wasn't already super overloaded and I could stick Docker on it. The machine that's running the robot has just a bunch of other stuff it's doing. I probably could run InfluxDB on it, but it might be a good idea to run it elsewhere just to spread the load around a little bit. So these are all the Docker VMs. There's Chronograf. I might keep running that in Docker because it doesn't really need much in terms of system resources. There's Telegraf. If I get into using this stuff for system monitoring, I might end up wanting to run a copy of this on all my physical machines too, maybe. But it's not even necessary for this. Capacitor, not necessary. This is just for Sandbox. And then here's the meaty bit, InfluxDB. I've managed to crash this Docker a couple times already by sending it queries that are too big. So I'll probably want to move this to a physical machine at some point, but this Docker Sandbox is a super easy way of getting it running. I did have to make a couple of very small changes to the configuration in the Sandbox to get this demo working, and so I want to show you those for completeness. So just to show you where I'm at, this is a clone of the influxdata/sandbox repo. I didn't bother forking this or anything, maybe I should, but I just have this in my working copy right now. Oh, this isn't even actually necessary. Yeah, actually, never mind. Neither of these are necessary for where we're at right now. These were just a previous test I was doing. So here I was exporting the stats-D port, which was that little UDP thing I was talking about, so that it was visible on the rest of the network. And then here I was trying a lower consolidation interval, trying to go from the default 5 seconds to 1 second. But yeah, I abandoned this approach because really I don't want 1 second, I want like 0.01 seconds. So yeah, that's no longer necessary. I could revert that. Let's just restart this for completeness, just to prove that we don't need those changes. And so the way this works, this is actually a Mac host that I'm SSH'd into. There's a VM running using some hypervisor that I actually haven't looked at much. It looks like kind of this weird Mac OS port of Beehive. But it's this like weird hypervisor they're using to run this single Linux VM, which then acts as a container host for all the Dockers. So it's this kind of weird architecture if you haven't encountered it before. Oh, I'm a little behind on YouTube chat. Sorry, I was just catching up a little bit. Pacosta Ferrer says that they've been lurking for a few days, and thanks to me, they've started taking logs on their projects. And up till now, it was just random notes, and now they're working on a proper blog, even if it's only for themselves. Well, that's pretty great. I actually I should get back to doing more of that myself, actually. I have gotten really bad at taking written notes ever since I started trying to video everything, because I just get used to recording stuff on the camera. But of course, like, that's not nearly as searchable as a concise notebook, so I should really get back into that habit. So we have Sandbox. If we do docker ps, we can look at all the processes. And if we do docker stats, this is like running top. It shows us the status for all these processes. So we're already getting connections. So because the metrics are batched up and sent over HTTP posts, when we restarted this VM, we lost a bunch of those batches. And then eventually we end up just like dropping the, well, actually they drop right away. There are some ways that we end up like, I was about to get on a tangent about how the threading model works, and I don't even need to go there. But yeah, if we restart the daemon, it'll just drop those batches. But you can see it, like, they come in kind of in big chunks. It just like sits there and kind of sorts all the data into the right buckets and flushes them all to disk, which seems like a nice way to do it. So then with that running in the background, we can just, well, if I just open this from scratch, if we go to that computer, port 8888, that's the Chronograf front end. What does it do if we go to the InfluxDB port in the browser, I wonder? I haven't tried that. Can you believe they used port 8086 for InfluxDB? The nerve, right? Okay, I guess the root address is a 404. What does ping do? Yeah, I don't actually know how to use the API in a browser, but I guess that's there. This is the nice UI. So I think this is like a front page that you can configure. I haven't set anything up here, so it's all just like welcome boilerplate text. But if you go to Data Explorer, you can actually just poke through all the raw internals here, or just like all the actual data in the databases. So Telegraph has a bunch of the stuff that it's been collecting, just like a bunch of normal stuff that you would expect to see here, like CPU usage, you know, typical stuff like that. You can also see all the internal stats for the database itself as a virtual database, which is pretty cool. So for example, I can go through here and look at how many HTTP requests are coming through, I think. Yeah, so these are actually incrementing pretty slowly because the batches are pretty big. Database. Oh yeah, these are the number of measurements and number of series in the database. That's a total. I think TSM is the actual data structure, so these are going to show actual like interesting, juicy metrics for the underlying data store. And then wall is write ahead log, so I think that's where we're going to see the new data going in, maybe. Although I don't really know what I'm doing here, I'm just poking around. Write OK. Ooh, look at all them writes. Yeah, tasty. So yeah, I'm sure that's fun. Anyway, the stuff I put in here is under Tucoflyer, obviously. So we've got the camera, object detector, and region tracker. One thing that I was able to do in switching from statsd to directly writing to InfluxDB is instead of sending all these like single values that are just like a string and a number, I could start to actually send structured data, which is super helpful here. So for example, in flyer.sensors, these data points now actually map directly onto Flyer sensor packets. So it gets one data point, and each one actually includes like all of the data from that particular point, and I can get them all together with the same timestamp, just like they actually arrive, which is great. I can also add additional keys to these data points. So for the winches, that's how I represent the different winch IDs. So if I just selected force up here, this is actually averaging the force for all the winches, or rather, I think the maximum force for all the winches, the way this is set up. I think I switched the aggregator to max. But if I hit just 0, I get just winch 0. I could get just winch 2. I could average winches 0 and 2. But I could also group them out by ID, which is usually what you'd want to do here. And now I can see all the winches separately, which is great. And now immediately you can see that like you've got these long-term effects where there's some kind of sagging here happening over time. I don't know how much of this is the load cell and how much of this is the nylon cords. I'm hoping it's mostly the nylon, but who knows. And then nicely you can just like zoom into the actual operations that are happening. So it looks pretty chunky here. So this is some quirk of how Chronograf works, but when you're in this query mode in the Data Explorer, it doesn't really want to give you any higher resolution than 1 second, but the database definitely supports that, and if you edit the query, you can get it to do that here. So, like, for example, actually, I don't know the easy way to do that in this tool because I'd have to, whoa. So when I do this and just like select a range and zoom, it's zooming the client-side graph, but I don't think it's actually reissuing the query. Whereas if I go over here to dashboards, this is just like a different part of the same app. But this has some nicer features for adjusting the timescale at runtime. So this is just something I set up earlier that has graphs for the forces on the winch, velocity, the motor PWM, the position error in the PID loop, and the manual control inputs. This is set up for the past 15 minutes right now. But if I go to the past 5 minutes, it would just be pretty solid. If I went to the past 12 hours, you could see this is all the data that it's collected since I started this version of the database at 1720 apparently. But once you're at this level of granularity, you can actually like zoom in here and it redoes the query and gives you higher resolution data. So like for example, if I'm like, whoa, what happened around here? This was like 8 kilograms. It shouldn't ever be that high. What happened? So let's like zoom in there. And so we can get a little closer, a little closer still. This is what I wanted to use the tool for, right? Collecting kind of semi-historic data for how the winches have been running so I can investigate anomalies, look at trends over time, and then actually investigate individual like actions to see how well they're performing. So for that, let's look at something with a single discrete move maybe. Do I have some of those over here? All right, so here you can see a couple things that I'm doing. So here's a move operation. I tried to order these roughly in the order of, kind of like the order of causality, I guess. So, oh, why are I think the forces graph being off screen might have had it not load. That's interesting. I might be low on pixels here. I might have to make this a little smaller for this computer, or for 1080p. I mean, I can tile these in other ways. I just wanted them to be vertically stacked so that the times all line up. There are other ways to do this. Like you can put them in a grid and still rely on this like vertical cursor to connect them. So let's try to dig back into something interesting, like looking at the manual controls again, maybe over here. Huh. These graphs aren't really staying in sync with each other when I zoom. That seems like a bug in a chronograph. Let's get like an hour granularity. And then maybe zoom in on something up here, like... I mean, we could also just like make some moves right now and look at some recent data, but it's interesting just to like demo how well this works on historical data, since that is actually a pretty nice use case. Like look at something that happened earlier today and see what happened when that was going on. So I think down here you can see Here I'm just like pushing, that's the z-axis. So I'm asking the winch to go up, and that'll have all the motors pull. And so you can see here, all the motors are actually going in the same direction. The position errors for all the motors climb, and then that eventually causes the PWM to climb. That is still not staying in sync, is it? And if I double click this, it starts to rescale, and then the whole thing zooms out, which is not what I wanted. So that's kind of frustrating. There might just be some UI bugs here, or maybe I don't know how to use it. I'm not really sure yet. This thing that pops up over is helpful, but it's also always in the way. I wish it was elsewhere. So, and yeah, like obviously it's all open source and I could like fix it. I just don't know how it works yet. And like the first step of fixing it is understanding it. So, that was almost where I wanted to zoom in. And if I shift drag, that moves the graph, but it doesn't move the query. I think, like, so this is the query range. But I don't know how to slide the query range. Like, do I have to choose a completely new one? See, this is... It's funny, because like the database is perfectly happy to give me data with like nanosecond resolution, but a lot of the UI features here are really designed for people looking at data at a much broader time scale than I'm interested in. Like, I want data between like this millisecond and that millisecond, and it's like giving me a date picker. So anyway, I might have to take a little detour to figure out how to use this UI later, but for now let's just look at something more recent. That's also an excuse to drive this around some more, which might be nice. Do I have a layout with both of those on the screen? So I can drive it around and show you on this camera. This camera's a little bit laggy, but it's kind of a nice perspective. Let's see if I can maybe overlay this and the computer. Alright, I'm going to make the computer view a little narrower and then just stick it down there. Or maybe up here. Just over the date stamp, maybe. I think I need to keep it pretty narrow so that we can actually see what's going on in the room. So this isn't going to be nearly as up to date as the data we would get from the web interface with Smoothie Charts, but once we've seen something, we can like investigate it in detail and save the data off, which should be really interesting. So we can update every 5 seconds and then show data from the past 5 minutes. You can also see that the data is coming in at a bit of a lag here. I don't know how much of that is actual latency and how much of it is system time offset. I could believe it's some of either at this point, and I haven't actually characterized it. Oh, let's make this presentation mode. Right, it keeps telling me how to disable it. I've got to actually remember that for that to be useful. That just disables a lot of the UI Chrome, so I can get this more in there. Alright, so overhead spool. Alright, it would help if I used the right. I keep using the wrong joystick by mistake, which actually aims the camera, which is also reminding me I should enable the camera. Let's put that down there. So we can aim that back at Tuco. All right, now I can move this. So I've gotten a little better at actually driving this thing around. I've also tuned a few of the parameters, increased the maximum speed, increased the responsiveness a little bit. It still needs a firmware change, I think, for it to really be as good as I'd want it to be. I need to compensate for some of the friction that's happening in the gearbox and the rest of the winch system. And so there are two changes I want to make to the firmware to help with that. And I talked about this in more detail in the last stream, so I won't go too much into that. But one of those will be to decrease the pulse width modulation frequency, since in this case, that actually helps us transfer more energy into the motor without having to overcome the inductance first. And any resulting kind of mechanical, like torque hammer effect that we do get is actually useful rather than detrimental. So there's that. Probably around 100 hertz is what I would aim for. So not especially audible, but potentially torquey. So that requires changing the firmware. The other thing I want to do is add an option. Whoa, that went into a bit of a compensation runaway. Oh, that was me actually driving it backwards. I had the like upside down coordinate system in my head problem. So I'm just gonna try to drive it in like a semi-smooth circle-ish thing around the room, but given that I can't really quite see it from where I'm sitting, this is gonna be difficult. Yeah, I had a bit of a close call earlier today. I was driving it and I managed to go somewhat fast, a little too close to the ceiling, and it got really high tension as all the winches pulled against each other. And I got a tension spike around like 8.4 kilograms or so, which is more than the load cell's rated for. And I had a close call where I thought it might have like broken a gear or something, but as far as I can tell, the winches are fine. It's pretty smooth other than the like creaking from the winding you're hearing. And I have to move it slow enough to keep the force compensation from oscillating. But, and the vectors are completely wrong because it doesn't really know where it is. But other than all those caveats, it's pretty smooth. Oh, Tuco's kind of interested in it now. He was completely ignoring it before. That was like a fast-ish movement, and then I let go and it kind of takes up the slack. Oh, and then that was me stopping it before it knocked something over. So yeah, it's a little hard to drive, but it's interesting. You can see the database filling up now. Alex, just catching up on chat a little bit. Alex says Splunk might be good for grabbing data at that resolution. What is Splunk? I've heard like the name before, but I have no idea what it is. Like so many things in technology. Let me do a quick Google for that and see if I can understand it in 10 seconds. Splunk costs. That's cute. It's a common fallacy. And Ryan is wondering where I'm attaching the cord on the flyer, on the top or near the center of mass. It's like centered in the XY plane and near the top in the Z-axis. But it's like not a single point. It's like around the perimeters of like a disk. So some of the force ends up going into tilting that disk. Is this a program or like a company or like a service? I'm skimming so much marketing without having any idea what this thing does. This looks like Prometheus, which is something else I looked at a little bit, but yeah, like, I don't know. Maybe this would be another way of doing it. It seemed like from my brief look at this space of kind of thing that InfluxDB was a pretty good option. Alex is also telling me to Google Cubana because they won't tell me what it means. The web page doesn't tell me what it does either. This looks like a much higher level thing, am I not right? This seems like a cloud monitoring tool, whereas like I don't want a cloud monitoring tool. I want the thing that's like a couple levels of abstraction underneath that. Like I want the same kind of time series database you would use for that, but I don't want necessarily like something that's gonna like expect to grab the metrics individually with HTTP requests. So I'm like about to show you the thing that I came up with, and I don't need like to redesign it, but it would be cool to think about other ways that it could have happened maybe. Ryan says that Splunk and Cubana are both for text files. Yeah, that. I mean, I've heard of people using Splunk for like HTTP logs, and like the thing is, it's like in this space of like time series data, so many people are like so full of their particular application and how big and like shiny it is that you go and like find these things that are marketed for like huge enterprise apps, and then it's like, oh, is this gonna have trouble running like 4,000 like points per second on my desktop machine? Like I want something that's like kind of partway between like a traditional time series logging framework and something like a data acquisition card, or like a data acquisition framework that you would run with like a data acquisition card, like something that is not necessarily like megahertz, but maybe kilohertz. Yeah, and so it's taken a little bit of digging, I guess, to figure out which of these services, or not services, these are all just like open source daemons that we're talking about, which is like which of these projects are actually useful for this particular thing, like logging and analyzing kind of medium time scale kind of data from the robot. And so, yeah, I think the solution that we've got here is probably going to be all right. So let's take a look at what we've got so far. That was just the past 5 minutes. Let's look at the past 15 minutes. So now we've got this kind of blob of stuff that might be fun to look closer at. We can actually just zoom into that timescale. Yeah. And then maybe just look at how the motion starts right here. Oh, this has got to be a bug that I'm hitting now because the screen resolution doesn't fit all the graphs. That's weird. Can I work around that with zoom? That got them close to lined up, but they're still not really lined up. I don't quite get that. Maybe I should give up on vertical alignment. Maybe that is not the way of things in this dashboard. Anyway, this actually makes it pretty great to kind of diagnose what happened during some operation. So we can see that, like, first thing that happened, I started punching on the gas here. This is the y-axis on the manual controller. So we started out with a non-zero amount of position error here, but not enough to actually get the motors to move. And the PWMs were 0, probably because of some previous timeout that happened. And they physically weren't moving. Oh, and this isn't zoomed. And we can also see the forces don't change until over here. So then in this kind of causal relationship, that thing, yeah, I should learn how to customize this, because this floating window is getting on my nerves. So after the manual control has been up for a while, so it takes a little while before we actually see any motor PWM. So I think we're actually hitting 2 different consecutive dead zones. I think there's one dead zone in the manual control and another dead zone in the position error. And once we've passed both of those dead zones, so those are like, it's like one of several strategies for kind of smoothing over imperfections in the control system by kind of taking values that are close to 0 and squishing them all the way to 0. So if we're near the right position, instead of like trying forever to get to exactly the right position, we accept some error and just leave it alone. And likewise, with the manual controls, we accept that the control, like the physical control stick, is going to have some dead zone. Although I thought, now that I'm talking about this, I thought that I implemented that on the client side, so we wouldn't be seeing it in this graph, but maybe we have to look back into that. Maybe we need to look a little closer at the order of operations here. So we got a little bit of manual control. Oh yeah, I think this started right away. I think it was just subtle. Look at that. So the position error starts out right there. What is that actual number? That's like 9.6 times 10 to the minus 3. Yeah, it starts pitching up right away. It's just really slow because this is really small. So this number is getting integrated and multiplied by something and then added to this, basically. Can I back up by 1 zoom level, or is that not a thing this can do? I think I zoomed into a slightly different area, but maybe this shows it more clearly anyway. So I actually really don't want this overlay right now. None of these are useful, right? Whoa, how did I duplicate it? Huh. Not even sure how I would get this to stay put so that I can grab it with the inspector, actually. Fine. Anyway, what I was trying to illustrate was that you can use this to see what the hell's going on with your system. Maybe there are better UIs. There are, I'm sure, plenty of other options that you can all tell me about in the comments, so that I can then read the Google page or the Wikipedia page for like an hour before I can figure out what it actually does. But I think at least the process of getting the data into the database and the database itself is working out pretty nicely. So you can see the manual control starting up. That starts increasing the position error via the PID parameters. That also ends up starting to increase the motor PWM after we pass that dead zone. But then you can see it's actually quite some time before we get any velocity change. You'd expect some latency because it's a mechanical thing that has to move, but I think a lot of that is because we have to reach at least a fairly high minimum PWM value before anything is going to move, because we have to overcome friction first. Joel is asking if I take cryptocurrency donations. No, sorry, I don't do that yet. Yeah, so we could get some interesting data from here. For example, like, well, what was that motor PWM at when it started? Like 1,000 out of 4,096, I think. We could actually look at the velocities. Right now, I think I have this aggregating down to like, well, I say aggregating as if it's doing anything fancy. I just throw away data points if I have too many of them, because I don't think at this level of detail I really care about averaging between consecutive points that much. Ideally, I do something with like minimum and maximum and averages during the in-process consolidation before I send it to InfluxDB, but I don't think I care enough to actually write that code. I had something like that in one of the previous iterations of this when I was using that dipstick library, but it only worked for positive integers, so oh well. Let's go back to the Windows machine. Oh, Paul is saying once it gets out of the deadband, the proportional and derivative components, yada yada yada. Yes, I know. Yeah, no, the deadband isn't the major contributor to that. That's mostly the friction thing, which is like what I'm getting to. So the two, I mean, not that I'm getting to, I guess I already described that. The two friction compensation methods. So one was decreasing the PWM frequency, but the other was kind of pushing the PWM values further away from 0. So like that's what we're getting to. I'm just getting there. Oh, Tuco. All right, let's have some stuff. I guess I closed all the text editors. Okay, this is a little bit different than what we had last time. So in the last stream, I was using this library called Dipstick that had a nice, you know, a pretty nice, like, thread-safe stat aggregator thing that you can use in process. So you can just like stick stats anywhere in your code pretty much. It's pretty nice. You can just stick some code in there that increments some atomic variable, and then periodically, you know, every couple of seconds, dumps those out to statsd. So it's great if you want things aggregated infrequently and everything's a positive integer. But my robot doesn't live in that world, so instead I ended up having to implement something a little bit more custom. I tried a couple of other libraries that I found on crates.io, but none of them really did what I needed. So that was when I started looking for like lower level InfluxDB clients. So if you search crates.io for InfluxDB, you can see 3 clients. So I don't think Flux is solving the problem we're looking for. I think that's for queries, but let's just take a look at it, since I think I didn't even really look closely at this one. The repo doesn't exist anymore. That's a good sign. So yeah, this one seems to be kind of dead. And the other options are Influent and InfluxDB client. And looking at these, they seemed kind of similar, but it looks like InfluxDB client has been updated for newer versions of the protocol. Yeah, this one tells you right up at front that it's not actively developed anymore. It seems to have the things I would need, but at least here it doesn't mention the 1.0 protocol. Although that also doesn't mention this version. So I don't know, it might have been kind of updated by contributors, but then I went to the repo and looked at the commits, and I didn't really see anything that was about like the protocol. I don't know, I haven't completely ruled this out, but from what I was seeing, yeah, so like the latest thing that I saw that was related to the protocol was in 2015, and it was about version 0.9. So like maybe that's fine, but I wanted to look for something newer, and here we have InfluxDB client. And if you look down here, this was created in direct response to that other crate being kind of old, so this seemed like the thing to use. It is not the prettiest Rust code, but it seems like it'll do. Uses Hyper as its HTTP library. Supports authentication. I don't know if it supports HTTPS, but I don't think oh, maybe it does. Yeah, cool. I don't know if I need HTTPS here, because it'll be on a local network that is somewhat secure, but I would at least like it not to be completely wide open if possible. So it seems like a nice little client. I think it even has query support, just like basic queries. But yeah, basically it can create and drop databases, it can do some user management. Most importantly, it can insert measurements. Yeah, write points. So this has some unfortunate code in it. Is that in keys? So I posted a screenshot of this on Twitter earlier because I thought it was especially ugly. Like this whole data structure is just kind of a mess. Like, I don't know why this was ever something other than a vec point. Like, I don't know why they didn't just use this directly. Maybe they thought they would need some additional tracking with it or something, but then it's just kind of an inconsistent design, and like, why does this why is any of this, basically, is what I'm getting at. They even bothered adding a from iterator for that data type, so they can treat it like an iterable. So yeah, I don't know. The library has all the features I need, it's just not pretty, so I used it. And so as I was saying, that other library, Dipstick, which, just for completeness, let me point that out on crates too. I still think this is a pretty cool library. I might use it in the future if I'm collecting stats from an app and everything's an integer. It might even be nice to combine this with the direct influx driver, perhaps. Yeah, this was designed for Graphite or StatsD. Seems like you could make a backend for this that sends data directly to Influx also, if you wanted. But it's frustrating because this supports such a limited set of data types compared to what InfluxDB actually allows. So, on the bright side, I think the solution I ended up with is a lot cleaner, because instead of just sprinkling metrics everywhere in the code, which then end up getting locklessly aggregated in one place and then flushed out to StatsD, which was what I was doing with Dipstick, instead of that, this approach, I'm putting all the metrics in one place, and the metrics conversion happens in a pair of threads that act a lot like they're just an additional client on the internal message bus, just like the WebSockets client. And so there's this sort of interface. It's not, I was going to call it an abstraction, but it's just like a naming convention. It's just like anything that you can just kind of bolt on to the internal message bus is in this namespace of interface modules. So this is just the main function for the Rust library, or for the Rust bot server. The core logic for the bot is in this controller object, and then we have to connect it to some I/O. But then a lot of the other stuff we're doing just bolts onto that. So the whole web interface bolts on the gamepad interface, like you've seen me controlling it with this Xbox controller. That's all just added by this line of code. And then likewise, I can add the metrics interface now with this line of code. And then everything else I do is kind of quarantined nicely into this source file here. And this ended up being under 300 lines. And so this file has the kind of metrics infrastructure as well as the actual mapping between all the internal message bus things that we care about and the externally visible metrics. Son of the Cake says, "Good evening." Good evening. Yeah, it's like 9 p.m. here. So, sorry I've been saying so much today. Just like trying to figure out what to say next as I wind my way through all this. So that start function from main ends up here. These two arguments are really just ways of accessing the shared data structures that kind of make up the core of our robot. This config is really just stuff that doesn't change frequently. Stuff like what are the IP addresses for the winches, what are the calibrations for the winches. The most frequently updated thing in there is probably what mode is the robot in. So every time I poke the controller to switch it into like manual mode or halt mode or something, the config changes. It also changes anytime I change the calibration, anytime I drag a configuration slider in the UI. So it doesn't change that frequently, but it can change pretty much arbitrarily. So this is a way of accessing the most recent configuration, but if you're attached to the message bus, there's also a message that gives you updates as they happen. And then controller port is how you actually attach to the message bus, among other things. So that's what we're doing down here. Yeah, we get a bus receiver, which then is sort of a subscription that gets access to all the messages that go through the robot. So these happen at a pretty rapid rate. So this is the like multiple kilohertz kind of rate that the messages come in at. We take each one and pass it to this handler that's in this metric sampler object. The metric sampler gets this configured rate. I guess this isn't updatable at runtime. None of the metric stuff can really change at runtime, but it still needs like runtime updatable configs because, for example, if you recalibrate the winches, they need to use the new calibration when they send like calibrated like kilograms and meters and stuff to the metric server. So yeah, when you start this, this ends up connecting to InfluxDB, starting up an inter-process communication channel between these two threads. And then this pair of threads, this one will listen to the message bus, process all the messages, aggregate them into a batch of metrics in this mutable list, this mutable vector. And this just runs once per message. Every time we reach this batch threshold, which is pretty big, these are the like several megabyte long post requests that we end up with on InfluxDB. So I think when we get like 8,000 of these metrics, we flush them all to the database. And that just atomically, well, it doesn't need to be atomic because this is like single threaded code, but it swaps without reallocating between these two vectors. So we're kind of taking the accumulator buffer here, these points, and like kind of swapping it out for this empty list, which we then start dumping points into. And the list of like 8,000 or whatever points that we're about to send out, we send off to the batch sender thread via this channel. And so I wanted this so that we can decouple the HTTP post from the internal message bus. So if the post blocks for any reason, I don't want it to drop messages. So that's what this is for. If for any reason we take a long time to write the metrics to the server, like you can imagine the server kind of strings us along by answering the post request very, very slowly for some reason. This thread could just take a really long time, but we don't want to block this bus receive operation. So having a separate queue between that makes that really easy to do reliably. And then if this queue ever fills up with over 16 batches, which like we should never have that many batches in flight, if we ever fill up this queue, then we just kind of print off an error message and drop that batch of metrics on the floor. And then on this side, we receive those entire batches, format them correctly, and then just send them off to the InfluxDB client. And then we can kind of lazily create the database if we need to, so I don't have to do that as a separate step. And that's the whole thing. That's the whole client. There are a couple of classes this uses. There's the actual sampler up here. There's also this little time sync utility, which we use to convert Rust's internal instant data type into timestamps that we can send across the network by coming up with an arbitrary synchronization point. And then in the sampler, we just have a bunch of like, this is all like very ad hoc code. I can probably generalize this at some point in the future if maintaining this becomes too annoying. But this is just like written pretty straightforwardly, where for each message type, we keep track of a timestamp where this is like the last time we actually sampled, and then there's a sampling interval. When we actually take the sample, we just make a new point, fill it in with all the data we care about, and add it to the batch that gets flushed to the server later. So just pretty straightforward formatting code here. I think that's like mostly it for the tour, unless anyone has questions about the details here. As I said, all this is running on like kind of temporary Docker images right now, but I'll probably move InfluxDB to a physical machine, like probably a different physical machine, although it could run on the same machine. And then Chronograf will probably still live in a Docker. So yeah, it is nice having this data. You can already see a little bit of that sagging as I'm assuming that's the cord kind of tensioning in. But I did want to actually get some longer term data to see how well these stay in calibration. So speaking of calibration, I think the next two things that are up on my to-do list here are recalibrating all the winches and then making that firmware change. I think I might continue putting off the calibration because that requires running around the shop with the wireless mic and a bunch of little spools of wire, and that's not really the mood I'm in right now. I think I'd prefer to keep writing code. So, although there will be some running around to flash firmware on these winches later. Get so distracted by driving this thing. It's pretty fun. That was me hitting the camera with the wire. Let's not knock anything over. This is... When I'm operating this thing automatically, I really shouldn't have this spool below the level of any of the C-stands in the room, but that's the state it's in right now. I need to get a better view of this to pilot it. I give you a better view too. Let me get a better view of the cat too. That's better. Kind of up and over there. and like drive it over and say hi to it. Oh, that's a great question. Matt asks whether the winch telemetry is timestamped on the winches locally or if I timestamped the messages as they're received centrally. Yeah, that's a good question. It's the latter. I timestamp them as soon as I can within the Rust server, but they are timestamped on the central server and not on the winches. I don't know why I'm getting like a flashing white line on the screen there. That's interesting. Is that a bug in the web app? So yeah, the winches themselves, they don't really have any fancy timing. They just do everything in a fixed time step. So they have their own local 250 hertz tick timer. They synchronize all their local operations to that. Some stuff runs asynchronously, but then it gets synchronized as they send out UDP packets once per tick. And then, can I get Tuco on the video here actually? So you could make some assumptions if you assume that the UDP packets are evenly spaced, but we do actually just currently record just like a timestamp. And I think all the algorithms right now, they tend to assume fixed timestamp or fixed time step rather than using the packet timestamps when I'm doing something that's like a control loop. So all the control loops on the Rust side are driven by the tick frequency instead of the timestamps. But then anything that runs slower than a tick frequency or anything where I'm logging individual packets and graphing them, those use the packet timestamps. So the charts you see with both the web interface using Smoothie Charts and the InfluxDB Chronograf stuff, those are all using the timestamps that we took as soon as we received the UDP packet. Where's Tuco? I can see him on the overhead, but I think, oh yeah, he's just out of range of that camera. So yeah, it is pretty fun to drive this thing around. Yeah, let's at least work on the firmware before I get too distracted. But I'm really looking forward to, once this thing has a little bit more intelligence in how it drives itself, I'm looking forward to making this drivable with audience participation. Like the way that this will end up working is that you can go to twitch.tv/TucoFlyer or to the Let's Robot page for Twitch Flyer and use chat commands or local client-side UI in the website to actually move the flyer around. Could probably actually fly it pretty close to the camera now. It is super disorienting when I get the up and down Z-axis shoulders confused. Because that's kind of a non-intuitive, every time I explain these controls, I feel like, why are they so bizarre? But they do kind of start to make sense, and I couldn't really think of a nicer way to do it at the current state of the robot not really knowing anything about its own coordinate system. But there's X and Y plane is mapped to a joystick, but then the Z plane, or the Z axis rather, is mapped to the shoulder buttons, and they're analog, but it's one adds negative, one adds positive. And I have it mapped so left is negative, right is positive, which means left is down, right is up. but it's easy to get that backwards. Bunny Overlord says, what is blocking the flyer on the Winch Bots right now? Nothing really. I just wanted to debug the motion control with something less breakable than the flyer bot. There's a little bit of minor work that I wanted to do in order to get the winch set up. Or, sorry, not the winch, the leash, the other thing. I've got an anchor point for it right now that's alright, but I've been considering like modifying it slightly. And I just need to like attach the counterweights to the cable, just like some busy work like that I haven't done yet. But it hasn't really been a blocking factor yet, since I've just like wanted to put some more time into debugging the motion before I actually think about putting the robot on there. Made a few firmware changes today, or not firmware changes. I made a few Rust daemon changes today that kind of help out a little bit with this too, in changing how the force limiting recovery takes effect. So you might have noticed that behavior where, so like if I zoom it over a bit and then let go, there was a bit of a recovery there after I let it go where there was a line that was a little too slack and the winch took the slack back in. And that happens continuously. And so sometimes you notice it, sometimes you don't. Sometimes it's very obvious that it's a separate step. And I was having trouble with it oscillating. It still oscillates sometimes, but I think I've got it tuned such that it doesn't very much. That time it was pretty subtle. But yeah, there's no longer, like for a while I actually had a pretty separate mode switch between the like slack take-up mode and the normal operation. And it's got a slightly better way of blending those two now. It's still not perfect, but it's a little better. Geometry is getting a little weird near that corner. Also, it's fun to drive it in and just like try to get the object to move in a smooth way, like using, you know, human in the loop feedback. But for debugging the control loop, it's a little bit more useful to give it just like very simple impulses along a particular axis. Like that. I think that should look pretty rectangular if we look at that. Are we still getting data? There we go. The batches are just pretty big. Yeah. That's useful. Yeah, you can see some nice behavior here too. You can see it going into this, this is a low force limiting mode taking effect. Thanks for zooming. I didn't really need that graph anyway, but that's the velocity. So this winch here is getting really low. That's, you can see winch ID 2, it highlights when you put the mouse over that trace. That's winch ID 2. It's down to 0.2 kilograms, which is going to hit the low limit. Now it's like 0.1. That's definitely too low. So like I think it hit the limit right here, and the position error accumulator zeroed right there, which is one thing it does in that error mode. And then immediately that drops the PWM down. But it took it a while before it cleared the integrator. Is that what happened here? Because it was still driving in that direction, just not very fast. That's interesting. And then here it actually reset to 0. I think this hit a different timeout. Yeah, there's a sequence. This is actually implemented in the Winch firmware. This is it tripping the force limit, and then this is it tripping a timeout where if the position error is 0 and the PWM isn't for a certain period of time, it trips this and sets the PWM to 0. And then that expires and it resets. Is that what happened here? No, it reset because we exited the force limit because a different winch pulled us out of it. I think that's what happened. So yeah, that's cool. It's a nice little post-mortem of a particular event. Doing our best at that, at least. Oh, do we need to boop the Tuco? I think he's pretty comfortable down there. He'll probably come over here soon. I can't aim any further without changing my end stops and potentially going into gimbal buzz territory. Game of Knowing asks how the weight of the wire spool compares to that of the flyer. I'm not quite sure why that's a comparison, but I mean, it's a lot heavier than the flyer. The Winch Bots are, I think, like around 3 kilograms, 3.5. And then the flyer itself is 1.5 kilograms. And so if you're comparing all of the Winch Bots versus the flyer, they're much heavier. And if you're asking about like a counterweight or something, the current flyer design or the current winches don't have counterweights. It's all just held in place by the worm gear and by electricity. Okay, I think that's enough yakking about InfluxDB. I think that's something we can keep on using. The aggregation at 100 hertz and 8,000 records seems to be doing all right so far, but we can tweak that if we want. Oh yeah, the logo is an homage to Radio Flyer. That's also courtesy of Misty. That's their work. And you can find that in the in GitHub. Is it not here? Yeah, this one. It's in the Flyer CAD repo for some reason. Okay. I think we're just going to dive back into the firmware. I think the way we want to do this is SSH'd into a wirelessly powered and networked Raspberry Pi, so that then we can take it around the shop and attach it to these robots. So I guess I'll have to grab a battery. Be right back. That gimbal was a little bit unhappy. I don't know if this Pi is set up for Wi-Fi. I think we're gonna have to power it up with the Ethernet just in case, and then SSH in and check it out. Alright, Pi is on the desk. Can I aim at Tuco? Somewhat. Oh, sorry. Game of Knowing was asking whether my stand-in spool was the same weight as the robot. I completely misunderstood that question, sorry. It's about the same, actually. It's slightly heavier, but it's really close. Yeah, this spool is like 1.5 kilograms. The flyer is like 1.3 or 1.4. It might be a little heavier with the... Well, I mean, I'll have a counterweight for the leash, so the leash will actually be slightly negative weight. Yeah. Do we have Wi-Fi? Oh, we do have Wi-Fi. Can I just unplug the Ethernet? I'm gonna reboot that just to see if I can get the MDNS to show the right IP, but I think that's working enough for me. We can just SSH back in there and oh, do I feel like using SSHFS to mount the text file? We've been having pretty good luck with that lately. I don't know, I've had mixed luck with SSHFS in general, but just using it for like text files on a Raspberry Pi has been mostly good. Good. That is the right IP now. Can I has SSHFS? Can I type? Okay. So now we have a local text editor with the text files on the Raspberry. This is the bot firmware repository. Let's make sure that it's up to date. Yeah, so I was like last working on this in August. I mean, I made some small changes after that, but wow. Position error deadband. Yeah, so the other thing is this will require breaking protocol. We'll need to make some changes in both the firmware and the Rust server at the same time. There's no support for different versions of the protocol yet, so we just have to keep them in lockstep currently. So one thing we can do without breaking protocol is just changing the PWM frequency. Alright, so that's in here. It's not quite as simple as just changing this number, although we will want to change that number. How low can we go? What clock are we using anyway? I think this one's 120 megahertz. But then we have a 64x divider. So normally that's as low as you could go, but I think, actually, is that the only divider? Yeah, no, it is. That's like the reload value for the counter. I forget exactly what the terminology is for this particular PWM unit. Maybe we should grab the data sheet, but yeah, I think they start with like 120 megahertz clock. Anyway, we don't need to know exactly what the number is for this purpose because we have a sysclock parameter. So we, like, technically we get that parameter at runtime, but that's just like calculated based on the sysclock configuration. So we can grab that clock directly for the PWM, but we can also enable a divider. On this chip, that divider is in the syscontrol kind of peripheral area. So let's figure out how to do that using this particular driver library. Is it PWM div? So PWM div is the register. Yeah, this is what I want. So I want to like call this with one of those values. And then right, so we've got a 16-bit counter. We'd like to use a lot of that counter for actually counting. What is that like with different prescaler values? Counter rolls over without a prescaler. Oops, not not that. At 1.8 kilohertz, we could divide that by 64. That'd be 28 hertz. So I mean, we could use pretty much the entire counter and then set the prescaler to 16, and that would be about right. Hertz, wouldn't that be fun? We can just add to the existing interference. Yeah, let's just... I think I do still want the frequency to be configurable, because why not? I could use macro nonsense to paste that together, but I don't feel like it. So we have separate fields here or separate macros for PWM Hertz, divisor, and the particular syscontrol flag that we'll use. So then this needs to be the period in PWM clock ticks, because this is what we'll multiply the floating point value by before getting an actual counter reload value. Yeah, this has all sorts of fun failure modes, right? Editing motor controllers. At least it's not a three-phase controller. It might be that simple. I mean, I'm just changing its time base here. I mean, I haven't set the syscontrol flag yet, but I'm getting there. What's that called? Clock set. Well, let's see if that compiles. would be nice to try this out on the O-scope just to make sure the PWM is doing what we expect. So I'm going to lower this whole thing a little more to the ground just because I don't like only 3 winches holding something heavy high up in the air. And then I'll take 1 winch offline and put it on my desk so we can just take a closer look at this code with the O-scope. So I've got it placed somewhere. I should place it somewhere where that winch isn't actually holding it very much. That'll do. All right, so I've got it in a place. Can you see where it is? That's kind of hard to see, whatever. Let's at least get some graphs to look at. Yeah, look at them graphs. All right, so now manual winch 0. And I have run it into force limiting. I'm gonna manually pull on it so that I can give it even more slack so that I can actually mount it on the, or unmount it and bring it over here. Right, now it's back in halt mode. I'm gonna unplug it and bring it over here. This off somewhere convenient. Okay. Little winchy. This is winch 0, our first one. So now we just need to get the firmware wrench. Toby Rob is asking if the winch system has a mechanical dead man or if it spools easily. I'm not quite sure I understand the question. Do you just mean like what keeps it from unspooling by itself? It's mostly the worm gear in the gearbox. The control loop can hold it in software to some extent, but it's mostly the worm gear. There's enough friction that it doesn't move on its own. Which is partly why we have a high friction to compensate for it in the firmware. So here we are, full circle. The dark side and the bright side of friction. Alright, little winchy. Slightly warm, but not really, which is nice. And I need a USB cable. Alright, this is the debug port. You could totally have a hole cut in the front for this. I just didn't. I do need to power this up, which is probably easiest done just through the AC. Let's just get power and network on here. Oh, okay, yeah, Toby was, what they're really asking is, like, what keeps it from falling out of the sky when the power goes out, which is a great question. And yes, the answer to that question is friction. It's not something I would trust for a really heavy load, but this thing is light enough, and it's held by enough winches that are all together friction-y enough. Oh, there's a little split in this case. I just noticed that. I should glue that before it gets any worse. It's just, I must have over-tightened the case screws at one point. Let's put a dab of glue on there and get that setting ASAP. There's always that question, do I have a tube of super glue that's already opened that's still good? Oh, maybe this is one. Or do I have to open a fresh tube? Can it super glue, or is it rock? Is it? Oh, it's still glue. Cool. So the trick is to get it in the crack and not in the threads. Let's see if this still holds. Okay, I just dripped super glue, I think. I think it just landed on the outer case, but that wasn't good. I don't see it. I don't think it landed anywhere bad. Alright, that'll be fine. Alright, it's back on the network. Let's make sure we can run this a little bit in its current state. Yep. Paul says the gravitational desire for it to unwind is countered by friction in the spool and gearing and mostly by the worm gear on the motor. I don't know if I'd say mostly, but that is part of it, yeah. Never underestimate the friction of the cord going through all these strange rollers and stuff. Station 240 says that that glue goes through glue, goo, and rock stages. Yeah, that one might have been a little bit into goo, but it seems to be starting to cure all right, and it's just a crack in a only slightly load-bearing piece of plastic. I think I already had similar cracks elsewhere, because I'm noticing a little bit of glue residue on this side. Maybe I'll reinforce it a little. That's just part of what holds the captive nut in for keeping the side panel on, is all. Okay, so back to the Raspberry. Actually, it'd be great to do it before and after, so maybe we should get the scope on this first. And get this back on Tuco. Ed's like, why not just lubricate the cord? A thought occurred to me. I think bearings are still better than letting the cord just slip on all the surfaces, but sure. What is the easiest way to actually probe this? I think I'm going to stick the scope on an arbitrary PWM lead and not really care which one it is. I'm just going to bother with one of them right now. Make sure that the glue residue doesn't build up here, or glue fumes. Cyanoacrylate film or fumes discolor plastic really easily. I don't like them anywhere near my good plastic. Do I have a ground? Do I have a ground? I don't think I added extra grounds to this board. This board really has far too few grounds unless you add a bunch of headers. So that area would be a ground. I could solder that on there without getting in the way too much. Alright, that should be 5 volt, or not 5 volts, that should be ground. 5 volts is next door, which is why it was on my mind. There are still holes in the heat shrink from last time I did this just by sticking the oscope probe in there. Which maybe is what I do this time too. This just is going to require additional hands. That should be alright. Let me throw the power. I've really got to find a way to prop up my oscope probe because I don't actually have enough hands to hold this and everything else. Maybe my fume extractor can do dual duty here. This is when I really need one of those. Oh, you know, I have used that little like articulated alligator clip thing to hold scope probes before. I might have to use that for this. Let's see if that worked. No. This would be a great thing to have all sorts of breakouts for if I was making a board for this. I think I really do need to try to get the grabby thing under the insulation. Oh, that's right. There's another header on the bottom of here. There's like a stacking header on this board. I can just plug something into the bottom. There's almost no room for that. I might have to use a right angle header just to get it in there. Oh yeah, how am I gonna do that? I'm just going to put a single pin in here because I only need a single pin. I'm going to bend it so that it fits. I'm just going to grab one of the PWM signals. I don't care which one that even is. Contact. That's it. So that's for the reeling up direction. Ah, it's super noisy. Where's all that coming from? What is all that nonsense? Well, so there's that. This is just acting like my ground is terrible. Oh, that might have been a bad solder joint. Let's try the other pin. Oh, that's better. Yes, my ground was terrible. Let's fix that before it becomes conductive debris. Oh, that's better. There's our 25 kilohertz. So we're only seeing half the waveform here because I only got, oh, jeez, I only got that half hooked up to the oscope. But that's our 25. So now it's time to hook up, or to like reflash the firmware and see if we get our 120 hertz. Alright, so I have it in halt mode, but still powered, which is how I'm going to have to flash it. I think I can just hot plug this into the Raspberry Pi. Let's switch to that so we have a terminal. Alright, I should be able to plug this in and see the... sorry, the mic is pointing directly at the fan. Let's point it more this way, sorry. Alright, the Raspberry is still up. It's on battery power. Plug this in. Great, that luminary micro thing is the debug interface. So we already compiled the firmware. I don't think I had a target in here just to flash it. That's right, LM4 flash. And then gcc/tukaflare.bin. Here goes nothing. Let's be ready to hit the power. Oh, I have to run that as sudo. Sudo make me a sandwich. So the lights stop blinking for a sec while it updates. Now the lights go blank, and now it's flashing again. So the new firmware is running. Lights are flashing. Let's try this PWM. I'm gonna unreel it first just to give myself a little room. Ooh. That's definitely got a tone to it now. Huh. It's not terrible, it's a little annoying. It's a little hard to tell without looking at the graphs, but it seems like we've got better torque at low speeds. Oh, we are off actually. This is way faster than it's supposed to be, which is why it's sounding so tonal. That was like 1.9 kilohertz. Okay, well let's debug. Cause yeah, we shouldn't be hearing it this much. Alright, back in halt mode. So that was 1.9 kilohertz. Can I get some verification about what our actual clock frequency is? Where is that all set up? Yeah, that's the system clock, 120 megahertz. So is it exactly 1900? I'm not gonna move it to check right now, but let's just check if it's that ballpark. Oh yeah, that's just acting like I'm not actually enabling the prescaler. It might just be my frequency times 16. Yep, that's gotta be it. So we're just not enabling the prescaler correctly. Is there anywhere else this is called? Is there some kind of like flush that we have to do first? Just curious if anyone else is calling the same function other than like example code. I don't think so. Is there any example code that uses this PWM divisor stuff? Oh, I don't think oh no, it's in the boards, but I don't think this has a lot of example code. I don't think I would expect to find it there. clock set. Let's look at the implementation of that and make sure it seems fine, and then check the datasheet. I think we can kill this fan. That was mostly for the cyanoacrylate. Yeah, let's check the docs for this run mode clock configuration register. Because maybe there's something we have to do to make that active. So this is syscontrol RCC. And I need to save this to use a real PDF viewer, sorry. I'm sure I already have a copy of this downloaded somewhere, but I was feeling lazy. So yeah, syscontrol RCC. Beach Ball City. Oh, actually, I think I did still need the fan, sorry. If I can smell the super glue from here, then it's pooling up close to the plastics and it could cause it to discolor. And it would also be nice to get it away from the humans. And, you know, animals in general. Oh yeah, Andrew says they can't get over how nice the graphing interface looks. Yeah, Chronograf does look pretty beautiful by default, doesn't it? Just like aggregating the data, and it chooses nice color schemes, and yeah, it seems pretty good. I wish the user interface would get in my way a little bit less, but I'll probably figure out my way around that. This is the winch we've been working on, Winch 0. You can tell it's got the weird force patterns. This is like reset and clock control. Where's RCC? Wow, there are a lot of these registers. Am I looking in the right place? This is syscontrol RCC. Not CRC. Not CRC, actually. Is this the right processor? Am I looking in subtly the wrong datasheet? I'm pretty sure this is the right one. Yeah. PWMCC is the register. Is this library code wrong? I also have to set that to 1 to enable the divider. Use PWMDiv. Is that part of the syscontrol flag? RCC, man. What does this resolve to? I don't think this is the right register, but I'm still trying to get my bearings here. Like, this is pulling up a different processor. Why is this even compiling? Or does it mean something in the headers I've got here? Okay, this is the same family. Okay, we're getting warmer. Syscontrol RCC, do we have addresses? Sysdiv. TM4C129. I think that this driver lib code is not written to support the chip we're actually using. I think we're going to have to poke the register directly because this code is not correct. Oh, where is this taking me? Oh. Oh, you're just doing this as part of PWM clock set? I thought someone else was leading me towards sysclock. You know, maybe I just misinterpreted this because I was looking at, I must have been reading some documentation that was talking about that other series of chips where they're in that, the syscontrol registers. Because I think on this series it's, man, that's confusing. So, in that case, I'm going to remove that. Do we call PWM clock set? Yeah, maybe we never call this, and this is what we need. But I thought the deal with this was that there wasn't a separate clock divider for each PWM. Like, I thought we were talking about this on the previous stream, or maybe the one before that, and it came up that this chip had one divider that was shared between both the PWMs, which this seems to be different. Maybe we were looking at the wrong chip then. Oh, no, this is what we saw before. This TM4C. You know what? I might have just gotten the 129 and 123 confused. Because the chip we're using is the 129, but the 123, I keep seeing that also because it's like very close by, and it's also actually on this board as the debug controller. So I think I'm just getting confused about which chip series is which, and the two series have this annoying difference in the clock dividers. Ugh. Alright. So I think what that means is I can just replace this with PM clock set, PWM 0 base, does this include the use PWM flag? Yeah, it must. Right. Div 1 is PWM divider off. Div 2 is divider on with the count 0, etc. They just bake that into the macro. But that means I have to use the other variant of this. It has to be PWM sysclock div 16. Oh, what a subtly confusing difference. That's annoying. Okay, let's see if that fixed it. Gosh, this is so different, just in two chips, which are otherwise exactly the same. I mean, as far as the PWM goes. Okay, let's go back to the oscope, flash this. Oh, sorry about the YouTube stream, we'll get to that. Thanks for letting me know. Oh yeah, Andrew says they have a couple of L298Ns somewhere. They want to make something. Yeah, that's a good little chip. It's like easy to get. I used those for a previous prototype of the winch. I blew one of those out pretty quickly trying to use it to control this motor because they have way too much voltage drop. But they're good for smaller motors. If I was going back to a design that used, like if I was redesigning this and doing the design that I've been talking about that'll use two motors, then that would make an okay motor driver for the little motor, and then the big motor could use like a big brushless ESC. Okay, that's flashed. Realizing I need to reel up my solder spool over here. Alright, that's flashed. Let's try moving it. Manual mode. Take up. Oh my gosh. That low frequency PWM is... that feels formidable. It feels like it's not working, but it just... that's how it's supposed to work. Let's try that again. It's just alarming. Unspool a little bit. Wow. That does seem to help with the friction. The whole thing just vibrates. Wow, okay. How do I feel about that? Kind of sounds like BART. Maybe I know how the BART engineers feel now. Like, it kind of works, but it's just like, ooh. Right? The multiple of 60 hertz makes it sound pretty angry. We could try a different frequency. We could go up to, I don't know, something a little higher. Is higher gonna be better? Do I want to double it? Do I want to make it like a different harmonic of 60 hertz or something, or just stay away from 60 hertz entirely? What does 150 hertz look like in this divisor scheme? Yeah, 150 hertz would be alright. That gives me a PWM max of exactly 50,000. That's only slightly higher than what we've got. Let's just try that. Make flash. Oh, always kind of nerve-wracking flashing firmware on something connected to a 100-watt motor driver. 440, yeah. I think 440 might be annoying though, because that might be too musical, but yeah, like, I mean, 440 is a very, very common frequency. I'm sure anybody who does music knows what that is. Yeah, I mean, we could try that just to see how it sounds. So anyway, I just flashed it with the firmware for 150 hertz. That does get it farther from angry power transformer and further into, like, your BART train is ready to take off. I mean, the same thing that's producing the audible vibration is what's reducing the friction problem, or the stiction. So, like, it is actually good, it just feels unsavory. I mean, the 150 hertz is definitely better than 120. We can try going up, just to see what that's like. Get a closer look. Yeah, I mean, I think I still want that linearization change that I've been talking about, but I'll need less of that if this is doing more of the work. It's also kind of an obvious question, like, well, why don't you just make the PWM frequency configurable, right? I mean, I could make it configurable in the EEPROM. I have a system for that. It would be, I don't know how much I care about that. It's like, the EEPROM I mostly use for stuff that's actually different per robot, and so it's like not really easier than like putting something like this in the firmware necessarily. You still have to connect to it over the debug interface to change it. In that case, it's like a serial port. The way to make something easy to change is to put it in the actual control packet, so it just gets sent continuously by the controller. But that means we have to be able to change it at any time, which I don't know if we want that kind of flexibility, like being able to change the timer between any packets. We would just want to be able to do that only when necessary. Like, I don't think we want to have to synchronize timer period changes to every single tick. We could, I guess. Oh, hi. Hello, Dexter Slab. Nice to see you. Yeah, so I'm We were talking about metrics and graphing and stuff earlier on the stream, and now I'm kind of digging back into Winch firmware to try to optimize it for better behavior around the friction in the assembly. So we're doing kind of two changes to try to help with friction. One is what you're seeing right now, just cranking down that PWM frequency to try to use the kind of torque pulses to our advantage, which seems to be working. I'm just not sure how I feel about how it sounds now. And then the other change I want to make, which requires a protocol break, so I've been putting that off a little bit, but oh yeah, I keep putting this into halt mode to halt all the winches, and then that makes it stop tracking Tuco automatically, because right now those functions are already linked. Gotta remember that. So yeah, so I think we might have done the PWM change. We'll think about the frequency, maybe try a couple others, but the next thing to dig into is adding an option. This time it is something that's easy for us to include in the control packet, so we can just change it any time. And add an option to kind of put a gap in around 0 so that positive PWM values from the PID loop turn into positive value plus some offset, and likewise negative values have an offset too. Kind of pushing us away from 0 to linearize it a bit. So any other frequencies we should try? Somebody was saying 440, 432. Which of those, I mean, I guess if we want a tiebreaker between 440 and 432, which of these actually divides into my clock source better? So we can bump up to a prescaler of 8. Yeah, we have to use 8. 8's the only one that fits. Well, we could use 16, but it would be a waste of resolution. And then neither one is an especially good number. Then we get a divisor of either 34,090.875 or 34722.125. Meh. They're both a similar amount off. Let's just try 440. It's a classic tuning. So recompile it to change the frequency. Flashing it. That's kind of weird. That's not terrible. This feels like it's also pretty good at overcoming the static friction. I don't know, that's not bad. And then temp is suggesting a lower frequency. Yeah, oh, actually temp was suggesting changing frequencies. Yeah, I mean, that would be an option to consider. That would require us, like, anything that changes the frequency dynamically, well, then we have to think about what happened during those frequency switchovers and, like, do that in a way that doesn't induce glitches. But, yeah. So Andrew says they understand why we're going higher because of the friction. Well, so the friction would be a reason to go low. I mean, just at a certain rate, at a certain point, like, we're going so low that, like, I think it's just not useful. Like, like I don't think I want to go anywhere below like 60 hertz. Like below 100 hertz is also still probably kind of low, just because like that's slower than my control loop. Like my control loop is running at 250 hertz at this point. Like it would be nice to have the PWM faster than the control loop. So, so there's that. But if I go too high, then I can't use this at all against friction, and then motor inductance causes it to be sluggish as well. So yeah, maybe 440. What is it like? I mean, 220 is still below the control loop frequency. Let's just try 432 just for fun. Because this is about the range I want. Something that's in the ballpark of twice the control loop frequency would be kind of handy, just for like efficiently keeping my like control loop latency as low as I can get using the current like frequencies. Like it'd be nice to have higher frequency than my control loop, and if possible like twice as high, maybe in that ballpark. 34722. Alright, I'm going to flash the 432 hertz firmware. Yeah, Dennis says now we're into audible PWM frequencies. You could place a binaural microphone on a winch payload and record an experimental drone ambient album during my experiments. Yeah, something like that. Something like that. Alright, that's programmed. That's kind of nice. That's 432. That's kind of a nice idea too. Ryan says set all the winches to different PWM frequencies and have them harmonize. Yeah, I mean, maybe it would be nice to have per packet PWM frequency control. I would definitely need an ISR synchronized with the PWM clock to do that. I'm also curious what the performance would be like with the low frequency PWM and the linearization versus just with the kind of linearization. Because we don't have to tread into audible PWM frequencies. That's just an option. I just thought it would help. But yeah, it would be interesting to have this be dynamic. I mean, let's see. Would we need to make it fully synchronized? I'm just looking at the code right now and imagining how this could work. Because right now we're driving all of this on the quadrature encoder interrupt. That's where we actually get the 250 hertz tick. It's not at all lined up to the PWM, but we could do something where, like, if the frequency is changing, we momentarily stop it and then restart it at the new frequency. That would cause a slight glitch, but I don't think it would be... I mean, what would be the worst case? if we reloaded the timer, then it would always start out off, or, I mean, I guess it depends on what polarity we set it to, but it gets complicated. Like, we have to think about the timing diagram of what happens during that period switchover. Oh, where is Tuco? He isn't taking a bath. Yeah, I'm really conflicted about whether I want to do the PWM here, the low frequency stuff. It would be really nice to have synchronized PWM frequency switching. So, like, the way I imagine this working is when I get a network packet telling me that there's a new frequency, that gets stored somewhere, and then next time I'm in my, like, per PWM cycle interrupt. That's the thing, is that interrupt is going to fire pretty frequently when we're at our high frequency PWM, but not so much at the low frequencies, so that'll be a little weird. Might want like a divisor also. Yeah, the timer setup could get complicated if I wanted to really squeeze efficiency out of that. Well, I'm going to put the dynamic PWM frequency thing on the back burner. I don't think that's really worth the complexity right now. But let's check in the change we have, because I'm kind of liking 432 for now. And we'll see how we like that, and move on to the next thing on the to-do list, which was the friction compensation. Do the push later when I feel like logging in. Okay. Oh, Tuco's over here. Andrew says, I don't know how to explain what I'm hearing, but it's neat. The faster the spool turns, the harmonics on the playback kind of sound like they're being run through a phaser. You might just be hearing the pulse width modulation. I mean, it is very in the audible frequency range right now. So you might just be hearing the duty cycle. You can just run this a bit for fun. Oh, wrong winch. So, if we're going to be messing with the protocol, that's a good point. I should actually turn off all the other winches so they don't respond. Let me just bonk their e-stop buttons. Alright, just one winch on the network. It should refuse to move in automatic mode now. Dexter suggests have it play the Imperial March while winching. I don't know if I'd be able to keep time. Well, I guess let's go over to the Windows machine to edit the Rust code. Not that Windows machine. Alright, messages. So some of these data structures also match the wire protocol that we're using. I think this is the module that actually sends the messages back and forth, but they're defined here. So winch status. I think really winch command is all we need to change here. So you can see this deadband is actually also part of the friction mitigation strategy. This is just something I added a while ago. So if we're close enough to the position target and we're stopped, then we just like continue stopping basically by resetting the position to 0. What do I want to call this? It is very close to the concept of deadband, so it's like, I might want to rename that also just to make sure that these stay very separate concepts. There are a couple of different strategies we talked about for this. The simple one that I'm thinking about doing first is just something where we push the values away from 0. We'd also talked about something where, just a different strategy where when starting the motor, you start it at a particular minimum value for some minimum duration, kind of giving it an initial kick. And that's something else to consider. I don't know how you'd integrate that in here quite as cleanly as I'd like. Okay, I think winch command gets its own UDP packet. How does this work? Yeah, winch command. We actually don't even have to really break compatibility that much. I can just add this to the end of that packet. Like one thing I could name this like friction compensation or something, but like that's kind of a misleading name because it's only one of potential several strategies that I'll try to compensate for friction. A more specific name would maybe be something like I don't know, like PWM linearization is maybe another name, but that also seems like it's less specific than I want. Could you go more literal and have it just be like minimum absolute value PWM? That's like very does what it says on the tin. I need to blow my nose, but I'll be right back. I'm gonna use a Kim wipe this time. Oh, crossover gap. Oh yeah, that's a good idea. Because yeah, in a class, like a class A or a class B amplifier, this would be a crossover gap. That's a good idea. I worry a little bit about using a terminology that's really specifically from amplifiers and using it in a slightly different way. Ow, PWM bias. I like that. Yeah, and like, I am also curious, like, should I should probably make this something that I add to the values that come out of the PID loop before they get clamped, so that it doesn't really have to have like a maximum or anything. I was thinking about whether this should just be summing a bias to the PWM versus taking the dynamic, like compressing the dynamic range, basically taking the values and like scaling them down slightly. But I don't think I want to do that. I think I just want to add. So like if I do just want to add, that makes bias a pretty straightforward name for it. Cool, thank you. In that case, I think I'm going to make it a PID parameter. Maybe. Why is Winch deadband not part of PID gains? I guess PID gains is very, very much just the P, the I, and the D. Where do I actually use the distinction here? Like, where does it matter? Why is this so huge? I think for a lot of folks it's just like PID dot whatever. I don't think I want it to be part of that. I think I'm going to have to put it down here. And I'm going to make it a float because I'm going to add this while the PIDs are still in float before we actually like integerize it all. I think that's the right way to do this for my needs. Cool. So the current behavior would just be PWM bias is 0. And then, so let's actually first update the Rust server so it sends out that field. The initial, or the current Winch firmware will just ignore it. So we can just send out 0, and then we'll add it to the Winch firmware. Although it's actually just almost as easy as sending out 0 to just send out something that's in the config file, and then we can update the config file later. Let's do that. Let's add this to config while we're here. I think those will be the same value. We'll just copy them. And where do we make these? Tuco is getting into stuff. He was right over there. Oh, there he is. Add it to the actual config file, and then maybe also add it to the web interface so we can edit. Bias is also AMP jargon. Yeah. I guess you're right, but it seems to make a lot of sense in this case. Alright, so that should make it editable. Also editable. Oh, interesting. We got one little metric write failure. Tuco, what are you doing? Oh, for halt mode. Right. That can be 0 in halt mode. So rebuilding the REST server, let's also rebuild the web front end. Let's try to change directories. I think he got one that he liked. It's a little slower to compile when I'm streaming. Concrete on YouTube chat was wondering if that was Tuco asking to throw a bolt. Yeah, totally. That was definitely Tuco's "Please play with me" meow. This would be a little faster if I wasn't creating a release build, but the debug builds of the bot server have a little bit of trouble keeping up with the message rate sometimes. Alright, so that should be sending out good messages. Let's see if that config is in the web interface. Didn't actually want to close this. This is on the debug server, or development server, but whatever. PID, edit, yeah, PWM output bias. So the output bias is going to show up in the quantized PWM values. Maybe in the floating point total, but definitely not in the PID contributions. I think I want to apply that before quantization, but after totaling. I'm just thinking about like where in the flow that fits in. Alright, we can go ahead and check in the bot server side of this change. Add PWM bias winch control parameter. Cool. Let's add the firmware side of that change. Okay, we can add that to the protocol. Oh, right. That does actually break protocol in more than just the command, because the command is included in the status. So it does like shift these down in the packet, so the status won't be decoded correctly until we update the firmware. So yeah, no compatibility there. So right here. I think I can say non-zero here, and that'll do what I want. We do need a way to turn this off, and there are various ways the PWM can get set to exactly 0, and so that I think is a valid way of operating here. So we'll have two states, biased positive, biased negative, and then we have 0. Increase magnitude of non-zero PWM values by this amount before quantizing. That's what we want. So that should match up the packet format that Rust knows about. And we just have to add it to the actual motor control loop. Okay, so it goes in here. I would like a better name for this distinction, because there's really any, like, only flimsy pretext for this function to exist. Like, well, why isn't that just part of the code down here? And if it isn't, I mean, it seems nice to split this up. Like, this is just in the tick loop. It's updating a bunch of other stuff. At the very bottom, we're updating the PID when we're not halted. Yeah. Let's just have this function set up all the precursors for this operation here. Take care of halting versus non-halt, because it's good at that. And let's do the PID update in that function. PWM PID update. Yeah, now this can just be all about the halting logic. That's much better. PWM PID update. Oh, was that just because I was calculating these elsewhere and didn't really want to store them anywhere? We can just pull those out of winchstat.motor. That's fine. When I hit Control V instead of Command V, because I forget what operating system I'm on. It will be set to actually like real 0.0 when I really want it to halt, but it might be nice to have like an epsilon value here that's close enough to 0. So I don't want to quantize it yet. do I? I don't think I do, but I want to test this against something that's similar magnitude. I don't want to do that division just for like a really ballpark figure here. It is nice writing code for a microcontroller with hardware floating point. Alright, let's reflash that. I heard the motor click a couple times. Okay. That's the bot on the desk. Alright, so if the bias we just added, it's right here. It won't show up in PID contributions. It should show up in PID command up here. Let's start by setting it to something non-zero but pretty small, like 0.1. Maybe a little lower, 0.07. Let's just see if we can see anything in the graph that would indicate that it's working. Alright, controller on, manual mode. Hard to tell, isn't it? No, we were going, was that us oscillating around 0? Oh yeah. Okay, I was wondering if I'd see that. Oh. So I think I want that to interact with the dead zone settings such that it doesn't stay driving the motor. Like, I I think I want the bias set so that the lowest PWM values are close to, but not quite, actually able to move under all circumstances. And then take up the rest of that slack with the position error deadband. Anyway, we're reaching about the limit of what I want to do with this on my desk. I think I might need to put it back on the wall and test it there with some actual load. What's it like with less of that bias? I think I just need more deadband. Huh. Why is the deadband not catching that? So... oh, is that just the integrator being full? I might need more integrator decay. I don't know. So we have the position error chomping down pretty quickly. Ah, that does sound like integral. Integral error decay rate. Well, it's much easier to tell what's going on just by listening now. It was actually kind of hard to tell what was going on with the PWM before. So that epsilon figure I added, I forgot about the integral not having a separate cutoff. I thought that might have had a deadband somewhere, but no, the deadband doesn't include the integral gain at all. So I might need a specific deadband for that, or do I need to rearrange the deadband code? This might be fine if I have enough decay, though, because it's not like this does this forever. The proportional gain will cut off as soon as the position error deadband is reached. And then we just have to wait for the integrator. I could also try to do something for the bias that's not such a hard edge, but like has some softness to it. Andrew says ADSR. Yeah, it does kind of sound like ADSR curves. Well, I don't want to move this too much while I have this cord like tangled up in all my probes and wires and stuff, but like, yeah, I want to move this around some more, so I think I'm going to put the cover on and get it on the wall. Well, I'm not going to put the cover on. I'm just going to put it on the wall. There's no reason to put the cover on. In fact, I'm still going to give this glue some more time to dry on the mount that the cover goes on. I will take the O-scope off of it, though, and give the scope a rest. Wow, it got late all of a sudden. Last time I looked at the clock, it was like 9, and now it's 11:30. Oh, there's Tuco. Can you see him? Oh. On the wall. Alright, it is plugged in and growling. Alright, I'm going to go into manual mode and take up the slack. Can we get overhead camera back, maybe? Alright, I think I'm going to aim the DSLR over at this winch so we can watch and listen to it as I drive this around a little. Alright, back in auto mode. Go up. Oh right, auto mode does not run because the other winches are off. Let's go back to halt, and I'm gonna have to... right, I can't do anything until I update the winch firmwares, except for run this in manual mode. So let's run it in manual mode. It sounds like Bart, and not in a good way. The motion's nice and smooth, though. I just hit the lower limit there. Well, Yeah, I kind of want variable PWM frequency. It's going to be annoying to implement, but I kind of want it. It's also late here. I'd like to wrap things up. So maybe what I will do at this point is, before updating all the winches, I would like to get this firmware to the point where I'm a little happier with it. And I think I am going to try to get the PWM frequency to be variable, maybe if not continuously variable, at least easy to set between any two control loop ticks. So I think my next step here is reading some data sheets while I get ready for bed, and then picking this up tomorrow with some additional firmware changes. Well, I think that's about it for this stream. Thanks so much for hanging out. I'll get this code pushed onto the GitHubs, and if you're interested, you can find it all at the Tuco Flyer organization. And you can find the videos on the previous milestones, previous progress up on scanlime.org. And yeah, I think that's about it. And happy hacking, everyone. Thanks so much for joining, and thanks so much to everyone who supports the channel, either by telling friends about it, by throwing a few bucks my way every month on Patreon, or by just hanging out. Have a good night, everyone.